So there are two main types of questions that come with the alpha plus beta, alpha minus beta formulas, or your sum and difference formulas. The first one we did last class, pi over 12 questions or 15-degree questions. And like I said last class, they're very common on the final exam. So a very important concept to understand. The second one that comes up a fair bit on final exams are these ones with the sine alpha plus beta, cos alpha plus beta formulas. I call these ones double triangle questions. Sometimes when we give a type of question a name, it makes it easier to remember not only how to do it, but also what the steps are. So this is called the double triangle question because you're going to need to guess how many triangles? 2. Perfect. So the reason we have to make 2 triangles is because they give us information about the angle alpha. So we're going to make a triangle for angle alpha, and they give us information about beta. So we're going to make a triangle for angle beta. Now, in all of these double triangle questions, they're always going to give you enough information to figure out what quadrant it's in. This one is really easy. The angle alpha with its terminal arm in quadrant 3. This is about as easy as it gets for figuring out what quadrant it's in, because they tell you directly. So when we're drawing our alpha triangle, we can draw an angle in standard position in quadrant 3. We draw it back to the nearest x-axis, so this right here becomes our reference angle for alpha. And if we know that cos of alpha is negative 3 over 5, that means that we know that the adjacent side here is 3, the hypotenuse is 5, and we could figure out the other side, a squared plus b squared equals c squared, and get that other side to be 4. So that becomes our alpha triangle. And our beta triangle, which I'm going to draw right underneath it, again, it's super easy because it tells us that it's in quadrant 2. And we draw an angle with a reference angle for beta back to the nearest x-axis. Since we know that sine is 1 over 3, that means opposite over hypotenuse, and we could do a squared plus b squared equals c squared and figure out that our other side is going to be the square root of 8. Now, given this information, we're told to find the exact value of sine alpha minus beta. So I'm going to draw a line here, and on this side of the line I'm going to write sine alpha plus beta. On the left side of this line I'm going to go to my alpha triangle and say, based on this alpha triangle, can you tell me what sine alpha and cos alpha are equal to? Well, cos alpha was already given to us. We already knew that that was negative 3 over 5. What's sine alpha going to be? Negative 4 over 5. Again, it has to be negative because it's in quadrant 3. And opposite over hypotenuse is 4 over 5. Same thing with our beta triangle. We can now do sine of beta and cos of beta. Again, we were given that sine of beta was 1 over 3. But now we'll know cos of beta. Again, cos is negative in quadrant 2. Will be negative root 8 over 3. If you wanted to simplify root 8 to be 2 root 2, you could, but you can also leave it just as negative root 8. So then sine alpha plus beta, according to our according to our sum and difference formula, it's equal to sine alpha cos beta plus cos alpha sine beta. And now you have to fill in the next line, and I'm going to do a survey on what happens with the next line. When we plug this in, what do we know? Do we know sine of alpha, or do we know alpha? Because if we know sine of alpha, Well, then we'll put in that whole value. Is sine of alpha negative 4 over 5, or is alpha negative 4 over 5? Sine of alpha is negative 4 over. We don't know what alpha is. So we can't plug in something for alpha. We know what all of this is. So we substitute the negative 45 for the whole sine of alpha. Same thing. We don't know beta, but we know cos of beta, so we substitute that whole thing in. Plus cos of alpha is negative 3 over 5, and sine of beta is 1 over 3. And now we can multiply things out. A negative times a negative is going to be positive all over 15 minus 3 over 15. We have to write our final answer as a single fraction. We already have a common denominator. So our final answer will be 4 root 8 minus 3 all over 15. You can't simplify the 3 and the 15 because with that subtraction, this gets grouped as one term on the top. And the only way you can simplify is if you could factor something out. And we can't in this case. Okay, questions you can do are 8 and 13.